Analysis of truss using method of joints. Step 1. Draw a free body diagram. That means remove the supports and put the support reactions. So AY vertical, DY vertical and DX horizontal at roller and pin supports. Step 2. Find if the structure is determinacy structure or indeterminate structure. To find this one, we have simplest formula 2J equals M plus R, where J is number of joints, N is number of members, and R is number of reactions. So in this case, J equals 1, 2, 3, 4, 5, 6, M equals 9, and reactions 3. So 2 times 6 equals 9 plus 3, which satisfies 2J equals M plus R equation. So the structure is determinate. The next step is to calculate support reactions. So for this one, we need to have some proper sign conventions as usual and take moment about the pin support, which is MD equals 0. Now AY times resistance 12 should be negative, 4 times 9 is anticlockwise positive, and 6 times 3 is positive, which equals 0. Solving this one, we get AY equals 4.5 kN. Now we can use summation of force in vertical direction equals 0. So AY and DY acting upward, 4 and 6 acting downward, so they are negative. It gives DY equals 5.5 kN. In horizontal direction, DX equals 0. Knowing both the support reactions, now it's time to analyze the joints. So let's start with joint A. First, make a free body diagram of joint A, which means removing the joint from the truss and using the member forces where the members are. So at member AB, FAB, and at member AF, the moment force should be FAF. And we need to find out the slope angle. Vertical is given 4 and horizontal is given 3, so we can calculate the sine theta and cos theta made by member AB are 0. And 0.6 respectively. Now you use normal sign convention, vertical upward positive and horizontal rightward positive for to use the equilibrium equations. So the forces acting are FAB sine theta upward and AY upward, which becomes 0. And substituting the values, FAB times 0.8 plus AY, which is 4.5 kN, should be equal to 0. This gives FAB equals 5.63 kN and negative. Now use a summation of horizontal forces equals 0 in that joint A. FAF horizontal plus FAB cosine theta equals 0. So now substitute the values of FAB and cos theta to get the value of FAF in the equation, and this gives FAF equals 3.38 kN positive. So remember the signs here. The negative means compression for FAB and positive means tensile for FAF. Now let's move to the next joint, which is joint F, and make the free body diagram with all the member forces. So remove the joint F and create the free body diagram with FFE, FFA and FFB are the member forces acting at joint F with the applied load 4 kN. Now use the normal sign convention and use the equilibrium equations, with summation of horizontal force equals 0 gives us FFA and FFE are equal,
FFA has already been determined from joint A, so FFE should be 3.38 kN. Now use the next equilibrium equation, which is summation of force in vertical direction equals 0, gives FFB minus 4 equals 0, which gives FFB is 4 kN. The positive values means both member forces are in tension.
Now move on to the next joint, let's say joint B, and make a free body diagram as usual. All the unknown forces should be tensile, which is away from the joint, and the forces that has already been calculated should be substituted. Those values should be used, and we need to know the angle made by the inclined forces to horizontal and vertical direction. So let's calculate. Let's assume them as theta and alpha and calculate the values of tan theta and tan alpha, which will be 53 degree and 33.7 degrees. Now the sign convention for equilibrium equations. Summation of force in vertical direction equals 0. Here FBA is acting downward, so FBA sin theta minus F and minus FB all are acting downward, so all would be negative. And substituting the values and solving, we should get FBE equals 0.916 kN, which is positive. That means this is the tensile member. And using the next equilibrium equation, Fx equals 0, and the force acting FBC, FBE cos alpha and FBA cos theta negative, and substituting the available values, we should get FBC equals minus 4.14 kN. Now let's move to the next joint, which is joint C, and make a free body diagram with all unknown forces acting outward and known force FCB value to be used, which is minus 4.13 kN determined previously from joint B, and find the angle of the inclined pole FCD and use the normal sign convention and equilibrium equations. With summation of force in horizontal direction equals 0, we get minus FCB plus FCD cos 53 equals 0. Substituting the value, we get FCD equals 6.88 kN negative, which is compression. And now moving to vertical force equals 0 equation, minus FC minus FCD sin 53 equals 0. Substituting the value, we get FC equals 5.50 kN positive. Now let's move to the last joint D and make the free body diagram on joint D. Reaction is already known, which is 5.5, and FTC is already known from joint C analysis, which is minus 6.88. Now we can calculate FTE using the equilibrium equation. Summation of Fx equals 0 minus FTE acting leftward minus FBC cos 53 acting leftward equals 0. Substituting the values, we get FTE equals 4.13 kN. Now let's check with a summation of force in vertical direction equals 0. FTC sin 53 plus dy should be equal to 0, and this equation is satisfied. This figure shows all the forces in kilonewton, and the reactions are also shown here, dx, dy and ay. Some members are in tensions with T in the bracket, and some members are in compressions.